Hello everyone, September 29th. Alright, so yesterday we didn't solve the problem, and mainly we got TLE. So, man, it asked me to log in again. So I actually thought about it afterwards, but I couldn't. Like, using my method, the bit masking, it just doesn't work. Alright, it doesn't work at all. So, because of that, I just submitted the editorial, and I actually took a look at it today. Editorial, yeah, I agree. This is a much better solution. It's actually quite standard DP. I don't know why I didn't think of it, but there is some very smart trick in this. So they have DPIJ, right? IJ indicates the indices from I to J, and then they just say, yeah, break down this problem, right? This problem is from this to this. We want to find the breakdown of triangles, so we can do any combination of start and end, which makes sense. You find any combination of start and end and find its minimum, and then you can do the top down, which is, honestly, it's not really that hard once you realize what this is about. Just giving any I to J, you will just go through all the K in between, right? And then you find an answer. Now, the really smart part is this key. This is a common trick, but I seem to always forget. When you have I and J, it seems to be a pair. Now, you don't need to do this as a pair, especially what the maximum value I and J can be. Actually, the maximum value of I can be. And then you can transform this pair into a single value. That is very smart. And then use that, you can just use one level of map to deal with this. So yeah, there are a lot of good things going on in this. I do have to redo this for sure. But we'll see what we have today, and then we'll decide whether we want to redo this. Okay, so we have something triangle again, which might be DP again. So we'll use what we learned from yesterday. Maybe they're very similar. I solved this one in the past. So a zero index integer array nums I is a digit from 0 to 9. The triangle sum of nums is the value of the only element present in nums after the following process terminates. Let nums comprise of n elements. If a equal to 1, end the process. Otherwise, create a new zero index integer, new nums of less than minus 1. For each I, assign the value new num I as this is basically the last digit, right? The last digit. Replace any number with new num. Repeat until we have 1. I think we can just iterate through because it's only 1000, so we can just iterate through. Okay, so this is actually different from what we have yesterday. I don't know, maybe there is a faster solution, but let me just get this one done first. Because 1000 will take 1000, so it's a million. I think a million is usually allowed. We can brute force this. Since len nums is small equal to 1000, we can brute force this. And I'm gonna just change nums directly instead of doing the other way. So basically we'll have int n, right, equal to nums.length nums of size, while n is larger than 1, right? For int I, 0i smaller than n I plus plus, In fact, I think I need to equal to 1, right? Because what I want is these two get this, these two get this. We say nums I minus 1 are equal to nums I minus 1 plus nums I mod 10. Right? And then we'll fill nums I minus 1 and then we move on. And then we'll do this once we're done n minus minus. And then we well, return nums 0 at the end. Is this used to be like this? I feel like it's not looking like this yesterday. Yeah, so that's very simple actually. And I feel like that's the only way to simulate. Is simulation the only way? Simulation. Yeah, it is simulation. Okay, so that's about it. We got this one done. I think we can go back to deal with this one. Wait, I definitely want to do it. Yeah, we have two solutions yesterday, but they're essentially the same. So this solution is inspired by the editorial. Okay. There are two key insights. First, you let dpij, okay, be the minimum triangulation score for subarray values I to j, and to find this value we iterate through all the k in between I and j, right? I and j. The termination condition is when I equal to, no, I plus 2 equal to j. 2, instead of using ij as a pair to form the key of dp, we use I times n plus j, where n equal to len values. This is an important trick to convert a 2D coordinates into a 1D index. It makes the memo much easier to set up. And I ended up with this O and tripled. Okay, so what do we have? So first things first, we need an unordered map int, this is memo, right? And then we say auto dp equal to capture I into j. Okay, so if memo dot contains we go int key equal to I int m and values dot size. So this I times n plus j. If this contains key, I return memo key. Alright. Otherwise it doesn't contain, then we need to find it. So we have ij. If I plus 2 is larger than j, right? So I plus 2, yeah, if it's larger than j, then we will return 0. If I plus 2 is equal to j, then we'll return values I multiplied by values I plus 1 multiplied by values I plus 2. Okay. Otherwise, so we have I and j, so we have something in between for int k equal to I plus 1, k is smaller than j, and then k plus plus. Okay. So for each one, we want to find I to k, right? So int left shall equal to dp I to k okay, I cannot do that. Function int actually I don't remember. How do I define in lambda function with type? Auto doesn't work. There's a return. Okay, so return is int. Then we need to do int. Okay, so left is gonna be this. Alright, I think I should do memo. So the key does not exist. Where do I do the minimum though? Here's where you do the minimum. We'll say memo key equal to int max, and here I'll say memo key will equal to minimum. This is left plus wait, hold a second. I think this shall return int max. Maybe not int max. What is our condition? 1 million. These are just impossible values. Right, I to k. Because it's not possible, right? Then why do you start with, you know it's not possible. You should start with I plus 2. And then you know this is not possible, so you need to go, because it's going to be k to j, so it should be k minus, so we have j minus 1, j minus 1. I plus, no, okay, j dp k to j. So memo key is going to be, we get a minimum of everybody. Once we're done, we'll return memo key. And we'll return dp from 0 to n minus 1. Okay, let's give this a shot. Huh. That's not right. I know, 3, 7, 4, 5, right? I want to find 3 and 5. So I have here, k, hold a second. Oh, k can be here. K is also, oh, I think I got it wrong. It is plus 1. So yeah, 3, 7, 5, right? If k is here, we have this 3, 7, 5. And then 7, 4, 7 to 5, right? 7 to 5. Well, how do I reason? Well, if we have enough, right? So basically we have all this. This is 3 and this is 5. If I have this, then it's going to be this to this. This to this. And then we have this, which is essentially what we have, right? Essentially what we have. But I think the difficult part is when we have I to k, when they are only 1 apart. When only 1 apart, it's going to be here. When only 1 apart, it's going to be here. I think this is not right. So basically, it's like this. They don't have another one in between. If they have another one in between, yeah, so I think, hold on, this is still right. I just need to consider this case. Yeah, if ij only have one in between, there's only one way. Right, in this case, it's going to be I plus 1, and j. Oh, it's not j. Huh. I don't know how to handle this scenario. Well, in this case, k is this. Then we do 7, 4, 5. Yeah, that's correct. Or I do this. I think, yeah, this has to be here, so k can handle this. Oh, it is 0 then. It is 0 because it doesn't exist. It doesn't exist. This 3 to 7. This is nothing. Does not exist. Oh, that's not v0. It's just 0. Yep. I think this one looks good. Solid. Yep. That's the one. Still took a while, and then like a few shots to fully understand what the implementation of this is supposed to be. All right, but that's good. That's good.